Welcome back to another session of Physical Sciences. As you know, when you see me, I'm doing chemistry. And today I'm going to go on with chemical equilibrium, and we specifically going to work and look at Le Chatelier, the Frenchman. We will look at his principle, Le Chatelier's principle and chemical equilibrium. So what we've done to date is we spoke about the definition of chemical equilibrium and dynamic equilibrium. We connected that to graphs. We did Kc calculations and Kc expression. And what we're going to do today is, like I said, we're going to look at the Frenchman's work, Le Chatelier, and we're going to look at his principle and how that links up to the equilibrium in chemical equilibrium. The terminology is Le Chatelier's principle, which we will shortly define. We're going to talk a lot about disturbance, or sometimes we will refer to this disturbance as the stress, seeing that the stress is what's going to happen at equilibrium after equilibrium has been reached. And then we're going to talk a lot about the word favored. And when we look at equilibrium, chemical equilibrium, we know that it must happen in a closed system, and it should always be a reversible reaction. So with the reversible reaction, we're also going to talk a lot about our delta H, or our enthalpy, and we will also refer to this a lot as we work further with Le Chatelier's principle and chemical equilibrium. The definition of chemical equilibrium, again, just to refresh your memory, it is a dynamic equilibrium when the rate of the forward reaction is equal to the rate of the reverse reaction. For a reversible reaction, and we remember it is in a closed system, the closed system means there's no interaction with the surroundings. Just want to take you back to the rate graph where we spoke about the rates of the reaction. We specifically looked at the rate of my forward reaction and the rate of my reverse reaction as we work up to a chemical equilibrium in a reversible reaction that is in a closed system. So we looked last time that our rate is fast at the beginning, slowing down for the forward reaction, and slow down, and then at this point remains the same. For the reverse reaction at the beginning, there's no product, and as soon as it starts to get product, the rate becomes faster and faster until a point where these two lines are basically parallel, and at that line or that point, the rate of the forward reaction is equal to the rate of the reverse reaction. We looked at this earlier when we spoke about the overall reaction for the preparation of ammonia gas. When we look at the concentrations again, just a refresher on concentrations. Remember, for the concentrations, we had 3 moles of hydrogen gas, 1 mole of nitrogen gas that produced 2 moles of ammonia gas. And we showed that in the beginning, the concentration of the nitrogen decreased, the concentration of the hydrogen decreased, and the concentration of our ammonium increased. I want you to see that our nitrogen decreases, but hydrogen decreases more. You can see on the slope that it's a bit steeper for hydrogen. The reason for that is they react in the ratio of 3:1. Then we come to Le Chatelier. What did Le Chatelier say about disturbance of that equilibrium? When the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. Oh, that's a lot that we've said. Must be in a closed system. It will reinstate the equilibrium by favoring the reaction that oppose the disturbance. The factors that will disturb the equilibrium is 3 factors that can disturb equilibrium. That is concentration. Remember we said the square brackets. Then we have pressure. Remember that pressure works hand in hand with your volume. So a change in volume can change or alter your pressure. And then the third one is temperature. When we look at Le Chatelier, we will have to have a way of answering Le Chatelier's questions, or we use Le Chatelier's principle to answer questions after equilibrium has been disturbed. So the first thing will always be to identify the stress. So we use the S. Remember that stress is actually the same as your disturbance. Then we will state how the system will respond to it and which reaction will be favored. Just before we go on, I want to explain to you what does it mean for a reaction to be favored. When a reaction is favored, it does not mean or indicate that the reaction happens faster than earlier. But favored means that the reaction happens faster than the reaction in the opposite direction. So if I say the forward reaction is favored, then I basically say the forward reaction happens faster than the reverse reaction. It's important to understand that. Right. And just to go on again, answering questions on Le Chatelier, the first thing, as I said, to identify the stress. When we know the stress, then we will respond and look at the response from Le Chatelier, which we call the R. Then which reaction is favored, we will use an F to remind us, and then the effect after the new equilibrium is established is our E. So instead of saying that is safe, when we answer questions on Le Chatelier or equilibrium, we will use, I want to say, we will use SREF method, S-R-F-E. And that brings us to the point where I think we all need now. Please come back refreshed.